Hi, my name is Blake, and today I'm going to show you how to create your own personal AI agent that has access to your personal knowledge base using a technique called Retrieval Augmented Generation, or RAG. To demonstrate this capability, I built RAG in a box, which uses Llama 3 and LangChain to provide a RAG agent right out of the box. All you need to do is provide your own documents to create a knowledge base. You can find the code for RAG in a box in the description of this video. This project is based off of a RAG tutorial provided by LangChain and 3 papers on RAG agents. The citations for these sources are in the description as well. Before I get into how the application works, let's look at a demo. For this demo, I provided my personal journal entries as the knowledge base, allowing me to ask questions about my journal entries. All right, let's look at a demo of the application and we can walk through what's happening. I just ran the model and we're going to start it up here by running the main application. So the first thing that happens is it automatically installs all the dependencies that we're going to need. All right, so the application just started here and it says, hello, I'm RAG in a box. I use Retrieval Augmented Generation, or RAG, to retrieve documents that are relevant to your questions and augment my generated response using the context from the documents you provide. Ask me a question, and I'll search through your knowledge base to answer it. So let's ask a question. I'll say, what is an activity I enjoy? So the first thing it's going to do is route our question. And it chose to look at our vector store, which is the documents that I provide. We can also have it route to a web search if we don't have the documents within our database. Now we are retrieving relevant documents from that vector store and then checking if the documents are relevant to the question. So 2 of them were relevant and 2 of them were not relevant. And now we are going to generate an answer based on these documents. Now we're checking for hallucinations, just making sure that whatever we generate is related to the documents that we pulled in. Then we are going to grade the generated answer versus the question. So we're basically saying, does the answer address the question? And it does. So we're going to return the result. And the result we get the question, what is an activity I enjoy? And then we're saying, based on the provided context, an activity you enjoy is skateboarding. You mentioned going out to skate and enjoying the weather and atmosphere in Boulder. And then we've got the context, which is the documents that we're using. And these are my private journal entries, so I'll block these out. But we can ask another question. And this time, let's ask, how does retrieval augmented generation work? And then we'll say, search the web. So in my journal entries, I don't have anything on how retrieval augmented generation works, but I can search the internet. Here you can see it routed the question to web search. It's running the web search, and now it's generating an answer based on documents it found from the web. And this is using a tool called Tably, which is a search tool for large language model agents like the one we're building here. All right, cool. So it generated our question here. The answer is retrieval augmented generation is a process that optimizes the output of a large language model by referencing an authoritative knowledge base outside of its training data before generating a response. And it goes to explain. And these are the documents that it retrieved. So these are from the web. It found these sources. And let's say no, done. The app exits out and you're all good to go. So now that we've seen a demo of the application,
let's walk through how it works. So when you clone the Git repository, this is what you get in the rag in the box. And the Jupyter notebooks here are how I prototyped the application. This notebook is actually from the LangChain tutorial, and I've modified it a bit. But it's really great to use the Jupyter notebook because it lets you use cells. So each cell we can run independently. Um, and it lets you play with the model in an easier environment. So I guess we'd have to start from the top here, but just as an example, if you want to look through on your own time, I'd recommend playing around in this prototyping Jupyter notebook. Now this is the document store. So this is where your knowledge base is, and everything is going to be a text document. And I set up a git ignore so you won't ever be committing this to GitHub if you ever contribute to this project. But as long as you provide text documents, Rag and Box can convert all of those text documents into a vector database, which is what's used to search through whatever arbitrary documents you provide. This process documents here, this is what I used to convert my journal entries into text documents. So right now we only have Google Keep. So I downloaded my data from Google, put it in this folder, and then ran this Python script to convert it to text document. And if you can use this script as an example for your own use case. So if you're converting a Word document to a text document, yeah. But if you don't want to do any coding, you can just copy and paste into a .txt file and put those here in the documents folder. All right, now this config here, I'll open my example config here. You can provide a LangChain API, and that will allow you to trace through the agent as it's working. So LangChain is a framework for building LLM agents, and they provide a way to trace through the agent as it executes. So giving a little bit of transparency into how the model works. Tavily is used, it's a web tool for searching the web for large language model agents, like the one we'll be using today. So if you want to have web search capabilities, you can also provide your API key here and just rename this file or fill in config.py. I have .gitignore on my config file because you never want to commit your API keys to GitHub. But you can just rename this file to config.py and it should work. Now, this is the real meat and potatoes here, the main.py application. This is where everything resides. I basically took everything from the Jupyter notebooks, each cell, turned it into a function, and then put it in the main.py file. So we'll walk through this function by function as needed. So we start by getting the dependencies. We looked at that in the demo. Then we initialize embeddings. So the way that a retrieval augmented generation agent works is it uses a vector embedding, basically embedding each document you provide into a space. It's not a 3D space, but you can think about it like a 3D space. Basically, each document is a point within this space. And when you provide a query, let's say you have a document about fishing and you provide a query that says, tell me about a time I went fishing. Well, if this point in space is where that document is, your query in space will end up near fishing. Whatever fishing represents in this vector space, it'll be nearby. And the agent will say, okay, what journal entries or what documents are nearest to this query? And it'll find relevant documents in that way. So in order to do that, we're using GPT for all embeddings, and this is an open source embedding model. Basically, it extracts the meaning of whatever documents you're providing, so that it can be embedded in this space for the agent to search through. And if you would like to see the test be run, you can set debug equal to true, and it'll just run each of these functions as a unit test just to make sure it's working correctly. Then we build the vector store, and these are interesting parameters to play around with. So chunk size is how large of a chunk of text you're embedding, and this basically can be used if your computer is slower. You can have a smaller chunk size. Chunk overlap is how much text in a chunk will overlap between one chunk and another. So if you provide a document with 10,000 words in it, it will chunk it into bits of 250 characters with no overlap. And you can play around with these parameters for your own use case, depending on the documents you provide. Now we create a retrieval grader. So each time you see this prompt here, LLM prompt, and then we initialize the agent. This is an area where you can play with as well, and looking at what the prompt does. This template here is specific for Llama 3. They have a specific prompt template, but you can mess around with the actual body of the test here, and I've done that to genericize RAG in a box. All the prompts are genericized for whatever documents you provide. But let's say you are creating an agent that is searching through technical documentation. Well, you might want to change the query to say you are an expert grader assessing whether a retrieved document is useful in a technical context or something like that. So you can play around with these queries, and what this specific step of the chain does is grades whether documents are relevant to a user query. So the point of RAG is to be retrieve documents, and we're also using ideas from these 3 papers, which can be found in the description of this video: adaptive RAG, corrective RAG, and self-RAG, to make the RAG agent more robust. So this step is helping filter out erroneous retrievals. Here we're creating the RAG chain. So this here is where the actual generated answer gets generated. So we are providing context in the form of whatever documents we retrieve, and then we're providing the question, the query that the human has provided. So this is the main RAG agent. If you wanted to cut everything else out, this is like the most basic RAG agent you can create. Okay, here we have the hallucination grader. This is another step where you check, once you've generated an answer, to help eliminate hallucinations, you check, is the answer grounded in the set of documents? And if it's not, it'll regenerate an answer, retry. If it is, it'll provide the answer to the user and continue. And here we have an answer grader. So this one assesses whether an answer is relevant to a query. So we're just providing lots of robustness. So you're getting answers that are actually valuable. And then here we're routing the questions. So this is an area where you can play with. Here you can see I have documents. You could create two vector stores. Maybe you have a journal vector store and a technical documentation vector store. And based on this prompt, you can route the query to different vector stores. And for this case, I am using Tavily to do a web search or hit the vector store that we have, which is built from these documents here. So based on how you write this query, you can route to different places. So for me, I'm just saying, if the user ever says search the web, then let's route to the web search tool and get documents from the web instead of from our vector store. And then here's the web search tool. And now here is the graph that represents the state of our agent. So each time that we are performing an action in this chain, we're going to update the state with whatever relevant information we need. So the steps in that our agent will do is it will retrieve documents, it will generate an answer, it will grade the documents, it will do web search if needed, it will route your question, and it will decide whether to generate or add web search. So, and this is, it will grade the generation of the documents versus the question. And it will check hallucination as well. Okay, and then here we are creating the app itself. So we're just adding all those tools we defined, building the graph and the edges that lead to different functions. So this is a way using LangChain to organize an LLM agent and make sure it has rigid boundaries that dictate what it can do and what it can't do. And then we create the app. And the main function here is where we start everything. So here's the user interface where we're printing out a welcome message. And then we're entering a loop where we continue to ask questions. And then this is where the action is, where we go through that whole chain of functions and events. And then the final step is we send that information to the user. And it'll continue until the user is done, and then it'll exit out. And then this is the application entry point where we set up the environment, create the agent, and then call that main function to get everything going. Now I want to provide you with a quick tutorial on how you can get all this set up. So if you're unfamiliar to coding, you may not have any of these tools, but I'll walk you through everything you'll need. So the first thing you should do is come here to visualstudio.com and download Visual Studio Code. This is an IDE, which is used for it's a coding environment. This is the application here. So it lets you open files and write code and run code locally. Once you've downloaded Visual Studio Code, come over to python.org, and you're going to want to download Python. So for me, that's Windows, and Visual Studio Code is a Windows IDE. So depending on your platform, you can find an IDE that works for you. But for me, that would be Windows, and I would download Python. Then once I downloaded Python, I would come to ollama.com. This is a platform for getting large language models, and we're getting the open source large language model Llama 3 for this project. It's the most powerful general open source model we have right now that can run on your local machine, even if it doesn't have good hardware. And that is one thing to be aware of, is a lot of large language model performance comes from the GPU. So if you don't have a GPU, it will still run, but it might be a lot slower than what you saw on my end. But a lot of laptops these days and computers have pretty good integrated graphics available. So once you've downloaded these three, you're going to want to come to the description of my video here, and we'll go to the GitHub link here. And once you're on GitHub, you're going to come over to code, clone, and then you can copy this to your clipboard. And we can come over here. This is within Visual Studio Code. Let me close this terminal so we can start from scratch here. So if I shut this, all right, we'll just start here. So if I say File, Open, Add Folder to Workspace, then navigate to wherever you cloned the repository. So I have it in Git repos. I'll go to Rag in a Box here. These are some of my other GitHub projects. Add that. That should add to your workspace here, and then you'll be able to open all the files and everything. So then we can go to terminal here, create a new terminal, choose Rag in a Box if it asks you there. And now here we are. So you can see all these documents here. So we are now going to run, once you've downloaded Ollama, in order to get the Llama 3 model, we're going to do Ollama pull Llama 3. And that will download Llama 3 onto your local machine. It's about 5 gigabytes, so it might take a little bit of time since, 4.7 here. So I've already downloaded it, so it was real quick. And you can make sure it is working by doing Ollama run Llama 3. And this basically runs the large language model locally and on your machine. So you can ask it questions like any of these AI assistants from your local machine. So I could say, hi there. And and /by to exit that. So now we've got our large language model set up. We are going to get the environment set up in Visual Studio Code here. So this tab here is extensions, and this lets you download extensions that help give you more capabilities and things. So the first one you're going to want to install is Jupyter. So searching in this box here for Jupyter, right here, these Jupyter, you can download it here, and this will allow you to interact with the Jupyter notebooks we have here if you want to do some prototyping for your own use case. You're also going to want to download the Python extension. So searching Python in there will get you the Python extension, and you can download that there. So once you have all the extensions, make sure you're within the Rag in a Box directory here, and you should be if you opened your terminal correctly. But ls allows you to list everything that's within your directory. So you want to make sure it looks like this with the main.py. If you're not in the right directory, you can use cd ... to go up a level. So here now you can see we are up one level in the directory. Or if you see you want to go into Rag in a Box, you can do cd rag in a box. And you can hit tab as well to autocomplete that. So now we're going to run the application. And the first time this runs, oh, sorry, that's not how to run it. You have to do Python 3 main.py. So this is the Python that we downloaded earlier. All right. So as we saw before in the demo, the first time that this runs, you're automatically going to download all of the dependencies that we need. So these are LangChain, and for the vector embeddings we looked at, and all of those other things, they will automatically be installed into your environment. and we'll just let this run to see what happens here. But at this point, you should be fully set up on the agent side of things. Um, we'll just make sure. And the last step you need to do is to add documents to this documents folder. So this is what's going to be used. Yeah, so here we have that. So I'll just Command C in order to quit out of that. So if you want to do it manually, we can do new file. We can call this doc1.txt, and then we can type whatever we want. So let's say if for some reason I wanted this, I could copy and paste into that. And then our next time I ran the model, this document would be added to our vector embedding space. So if you have a lot of text documents, you can add it here, or if you want to copy and paste, you can do it manually. The other technique, if you know a little bit about how to write code, is you can automate the process. So here in the process documents folder, my journal entries were in the form of JSON files from Google Keep. So each one of these contains information. And this right here basically will open each document and convert it to a text file. So if you want to experiment with code, you can even ask your Llama 3 agent to help you write the code to do this for your own use case. But yeah, you can also do it in an automated way to get all those text documents in there. So once all those text documents in there, you're good to go. Everything will be added to the knowledge base that the agent is going to be searching through. And then you can use it just like we showed here, asking questions as needed. Thanks for watching, and I hope you have fun building your own large language model agents using RAG in a Box. Leave a comment down below if you have any questions, or if you want to share what you've built using RAG in a Box or any of the other large language model tools out there. See you later.